All right, so today we're doing section 6.1, so we're done with chapter 5. We will still have the quiz that has 2 sections in chapter 5 and one from 6.1. So it doesn't mean that we're not going to test chapter 5 anymore. We're still going to take our test on Wednesday. And we're just going to be simplifying roots with variables. So roots meaning like square roots, cube roots, okay? We're not going to go into the 4th roots, 6th roots, nothing like that. So we're going to do the square roots, and we're going to do the cube roots, okay? So I put nth roots, meaning like the index is the thing that's going to kind of tell us what's happening with it, okay? So they normally look like this, okay? So you're going to have your radical like this, okay? And then you have some kind of number or something on the inside, okay? So we're just going to put an x here. You have a power, usually, not always. And then an index, the I on the outside. Now the index tells you what kind of root you're doing. So 4th root will have a little 4 there. Cubed root will have a little 3 where the I is. A square root, for some reason, they decided they didn't want to put a 2. But there would normally be a 2 there, okay? So I'm going to put right here, if I is, let's say 3, we call it a cubed root. If I is 4, we call it a 4th root. But if I is missing, that's a square root. That's the most common root that we use. It's a square root. Okay? So if I were to ever, and I'm not doing this in terms of notes, but just to show you really quick, guys, you don't have to write this part down, but if I just go like this, I call that the square root of 2. But if I go like this, that's the cubed root of 2. Okay? If I do this, that's the 4th root of 2. Okay? This is the square root of x, right? Because it's all based on the I. The index tells you what kind of root you're doing. So if there's a 6th, you say it's a 6th root. If there was a 10 where that little I would be, you call it the 10th root, okay? But if there is no value, I always tell people you can put your own little 2 there if you want to remind you square root, okay? But you don't have to, but it's just something you could do. So like I said, I'm going to erase this because this wasn't supposed to be part of the notes, just kind of a way for you to see what I'm talking about. Again, the nth roots look like that. I radical x to the p. X is our number that's in there. The p is the power that we're going to be using. Okay. Now, I'll discuss a little bit more about the relationship between the index and the power in a bit. Okay. We're going to discuss that in a bit. But for now, we're just going to try to figure out how to use the main roots, okay, the main radical, the square roots, the cube roots, without variables first, okay, just numbers first. So again, the I is the part you're going to be looking at, okay, that's going to tell you whether it should be a square root or a cube root. Now, when you guys look at your calculators, like right here on this black one, there's a button for square root. And then right above it, it says cube root. You just have to press shift on it, okay? Now, your calculator might be a little different, but I'll let you guys, like I said, get those later so you can play with them and stuff like that. So let me show you our first example. Now, if you have a calculator like mine, I can just type this in and it's going to give me the answer, okay? So my point is not to say, okay, push this into your calculator. Sometimes I might. But my point for today is to show you how it works if you didn't have a calculator. Okay, how do you look for it? So this is a square root of 48. Okay, because notice the index is not there. It's missing. So if the index is missing, it's going to be a square root. Okay, so what I'm going to do right now is I'm going to try to break this down into any multiple, okay, that gives me 48 lessons. Any multiple that gives me 48 that hopefully has a square root, okay? So I'm going to do a little bit of scratch work. Now I know 1 times 48 is 48, Okay, I know that. And 1 and 48 don't have a nice square root, right? They don't have it's not like, oh, square root of 48 is 8 or something. Like, no, it's not. All right, let's move on. 2 times 24. Does 2 have a nice square root? No, right? There's no square root of 2. Is there a square root to 24? No, there isn't. So I'm going to skip those. I'll move on. What about 3? Does 3 go into 48? Yes, 16 times. Okay. Does 3 have a square root? Is there a square root to 3? No, right? Is there a square root to 16? Yeah, what is it? 4. So I'm going to use this one because this one actually allows me to advance. So I'm going to write equals to the square root of 3 times 16. Okay? Now, we already said the square root of 3 doesn't exist, but the square root of 16 does. We said that's 4, so I'm going to draw an arrow. The 4 comes out, square root of 3, and I'm done. Okay? That's it. That's all you have to do. Now, I told you guys you can do this on your calculator, and it should be easy. Okay? Like I can just type it in, and it's going to give me the answer 4 radical 3. I don't have to do any of this extra work. But the reason why I'm showing this to you guys is what if you don't have a calculator active, okay? When you guys do state tests, they're not going to give you problems like this with the calculator. They're going to tell you do these without. So you have to know how to do them without a calculator. So I'm going to show you how to do them without. But once you get your homework, maybe try one without, try one with, try one without, try one with. Just so you can get a little bit of practice. But your calculator should be able to do these numerical ones, okay? It won't do the ones with letters. The ones with letters, you're on your own. You guys are going to have to do those little by little, and I'll show you how to do those. Now, we do have 9 examples, but it's because these don't take that long, okay? So the square root of 500, that's a huge number, okay? And I would like not to start with like 1 times 500, 2 times 250, but I could. It's not a big deal. But I know that there is no square root, excuse me, for 500, okay? So I'm going to break it down. Now, I could do 1 times 500 and start doing everything, but can you think of 2 numbers that give you 500, one of which has a square root? Think of 2 numbers that multiply to 500, but one of them is going to have a square root.
25.
25 times what?
20.
Is that 500?
Yeah.
Yeah, that would be, yeah. So that would work. That would be one of them. Can you think of anything else?
100.
So 5 times 100. I mean, I'm sure there's more, but those are pretty good options. I have 2 to choose from, okay? 2 of them that were given. I'm going to choose the one on the bottom, and let me explain why. 25 has a square root, right? Square root of 25 is 5. 20, can I break that down further? That's 4 times 5, right?
Yeah.
So that also has a little square root hidden inside of it. That means I got to do more work. If I look at 5 and 100, 100 has a square root of what? 10. Can I break up 5 anymore? No. So which one results in less work? The top one or the bottom one? The bottom one. So I'm going to choose the bottom one because, like you guys, I'd rather do less work, not more work, right? So let me pick 5 times 100. I'm going to show you what happens if you pick 25 and 20 though, okay? Because I don't want to just be like, let's not worry about it. Let me show you what happens with that one after. So this will be 5 times 100. The 100 goes out and becomes a 10. So that becomes 10 radical 5. Okay? Let me show you what happens if we pick 25 and 20. I'm going to do it over here on the side where all the scratch work is, okay? So what happens if I pick 25 and 20? Well, the 25 goes out, right? So that becomes 5 radical 20. There is no square root of 20, but I can break down 20 into 2 numbers that multiply to 20, one of them having a square root. I told you guys that would be 4 times 5, right? The square root of 4 is what? It's a 2. So the 2 is going to go out. It's going to become 5 times 2, square root of 5, and 5 times 2 is 10. Are my answers the same for both of them? Yeah, but one required just more time. So if you pick the quote-unquote wrong numbers, is it a problem? No. It just means you might have to do more work eventually, but you can still get the same answer. So we're going to try to pick the easiest option, but if we don't know, then we'll pick any 2 that work, and then if we have to, we keep working through it. Okay? So yeah, I would have picked 5 times 100 because I know 5 is a prime number. I can't break it down anymore. But 25 times 20 is equally good. I just have to work a little bit more. Okay? So either way, we get the answer 10 radical 5. Give me a second here. All right, so let's keep moving on here. So part C. Now notice this is a cubed root of 24. All right? Now for the cubed root, we're not looking for a number that multiplies times itself as a square root. Like square root of 4 is 2 because 2 times 2 is 4. Right? The square root of 16 is 4 because 4 times 4 is 16. Right? The square root of 25 is 5 because 5 times 5 is 25. The cubed root of 8, and I know that's not here, but the cubed root of 8, 2, because 2 times 2 times 2 is 8. Okay? The index tells you how many times you have to multiply the number times itself. So cubed root means find me a number that multiplies times itself 3 times. Okay? Well, is there a cubed root to 24? Well, let's see. 1 times 1 times 1 is 1. I'm sorry, yeah, is 1. I was going to say 3, but no, it's 1. 2 times 2 times 2, 8. Okay? 3 times 3 times 3, what is that? 27. Did I skip 24? Yeah, right? I went from 8 to 27. There's no cubed root that gives me 24. So now I got to think, okay, maybe I can break up 24 into 2 numbers. All right, so I'm going to go to the side here. And 24 is 1 times 24, but we already know 24 doesn't have a cubed root. 2 times 12. Well, there was no 12, right? Because we said 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8, and 3 times 3 times 3, that's 27. I'll do one more just so we can have it. 4 times 4 times 4 is 64. So notice there's no 2, there's no 12. So that means that combination is terrible. What other combination can I use? 8 and 3. 3 times 8. Now there is no cube root that gives me 3, but there's a cube root that gives me 8. Right? 2 times 2 times 2 gives me 8. So I'm going to use that one. So cubed root of 3 times 8. What's the cube root of 8? 2. So 2 cubed root of 3, and that's my answer. And if you did it on your calculator, it'll give you that same answer, 2 cubed root of 3. Okay? Again, the reason why I'm not using the calculator is because I want you guys to see it without. Like, what if you don't have one? Or what if you do have one, but it doesn't do the shortcut where it gives you that answer? It gives you like a decimal. Right? Then you got to know how to do it by hand. So I'm showing it to you guys by hand. Now, there is one, I don't know if this one, yeah. This one I said, use a calculator. Okay? So do me a favor. I'm going to pause the video. If you need to borrow a calculator, come get one. Just trade me your phone really quick and come get one because you're probably going to want to use it for the home. All right, forgot to press record, but we broke down 256 into 8 times 32. We took the 8 out. The cube root of 8 is 2, so that's going to give me a value of 2 there. And now I'm going to break down 32 into 8 times 4. And I know that the cube root of 8 is 2, so I'm going to take that out again. Okay? So when I take that out, I end up with 2 times 2 on the outside, cubed root of 4. And 2 times 2 is 4, so it's going to be 4 cubed root of 4. And this will be our answer. So notice here, I mean, we could have done it faster, picking better options, okay? But in our case, we just went with what we had there, okay? And we just kind of broke it down little by little, okay? And that'll help us get these problems done. So sometimes you're gonna have to use a calculator to break numbers down. Maybe you can luckily just punch it in, it'll give you the answer. But for the most part, your calculator should be able to do most of this, okay? Now, let me give you guys a not a definition, but a little Q&A here, something for you guys to write down. Okay, because what do you do when you have variables? So I'm going to go ahead and pause the video right now. All right, so the question here is, what do we do with variables? Like, what if there's variables inside, okay, of a radical? So based on the index, okay, so whatever the I value, so if it's a square root, you won't see anything. If it's a cube root, you'll see a 3, right? And we're only going to do squares and cubes. We're not going to do fourth root, sixth root. So we're only doing square root and cube root. So it's based on the index. Collect I amount of variables to take out. So like if it was a square root and you see x and x, you see a pair of them, that means you can circle them and get rid of them. A single one comes out. Or if you see an x squared, okay, I put right here, this can be done using powers. If your index and your power match, that means you can remove it. Okay? So if your index and your power match, you can remove it. So here we go. So I'm going to do this just because I like to do it. I'm going to put a 2 there. Okay? First, you deal with the number. Now, you can do this on your calculator. Press square root of 32. What is it going to give you for square root of 32? Someone tell me. You guys got one. 4 square root of 2. It's going to give you 4 square root of 2. I'm going to do it for you guys just so you can see it. But see what I mean? The numbers you can do on your calculator. The letters you can't. Okay? So just to show you, 32, I'm going to use 16 times 2 because I know the square root of 16 is 4. So I can write it out like this. Square root, I'm going to put a little index there, of 16 times 2k. I'm just leaving the letter by itself for now. The 16 can go out. This is 4 square root of 2k. 2k. Now look at your variable. How many k's do I have? Well, look at, well, it says 2k, but just the letter k. It's not k squared. K squared would be 2. I only have 1, right? And I can only take out a letter if there's as many letters as there are indices. So the index is 2. I only have 1. That means I can't take it out. If it would have been a k squared, then I can take a k out and it'll disappear on the inside. But it's not a k squared. Right now we're going to do one like that. So this is your answer for this problem. I couldn't take out anything. Now, if you want to erase the little index of 2, feel free. You don't have to have it there. So you can leave your answer like this, and that's fine. Yes. So like this. If I had this and the index was 2, it comes out, and there's nothing else left inside. Or if you see something like this, if you see a pair, because notice the index tells you how many you need, right? So 2, so I can take them out. If you see this, let's say we have like letter D, D, D. Well, I can take 2 of them out. This will come out, you get D square root D. One of them gets to stay inside. And right now we're going to work on stuff like that. So here's this one. And this one's supposed to be really easy. What's the square root of 64? 8. And then the square root of x squared. I'm going to put the little index there. You see how the index matches the power on the x? That means I can remove it. I can move this out. And it just becomes a solo x. And there's your answer. Now again, on your calculator, you can press it square root of 64, but you're not going to be able to put square root of 64x. Okay, it doesn't do letters. So you got to know how to do the letters yourself. All right? So when you have two variables that are the same inside of a square root, you can take them out. It's going to disappear from the inside. It becomes a solo one on the outside. Okay? Just a single. So check this one out. I don't know if there's a cube root of 875. Let me check. No, there isn't. So we're going to have to figure that one out the hard way. Okay? So, cubed root of 875. That means I need numbers. I need to divide this by numbers that give me 870 or 875, but by multiplying two numbers. So let's see. Now numbers that have cubed roots. Let's see. So I know 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Can I divide 875 by 8? No. Okay. 3 times 3 times 3 is 27. 875 divided by 27. Does that work? No. What about 64? Because that's the next one that goes cubed. So 875 divided by 64. I didn't show you the next one, but I should have. I'm thinking the next one's going to work. That one doesn't work easily. Let me see. Let me see if this one works. Yeah, it does. Okay. So I showed you guys 1 times 1 times 1. 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27. And then I stopped at 4 times 4 times 4, that's 64. I should have gone one more. 5 times 5 times 5. That's 125. Divide 875 by 125. And what do I get? 7. Okay? And 125 has a cubed root of 5. Okay? So here we go. Let me write this out. So this is 3 cubed root of 125 times 7, excuse me, x to the 5th. Now I'll fix the x's right now. The 125 can go out, and it becomes a 5. So I get 3 times 5 cubed root of 7 x to the 5th. I'm just doing this in 2 steps because I don't want to confuse you with numbers and letters.
Why is it multiplied by 3?
Oh, there's a 3 outside already.
Oh, that was in the...
Of the original problem had it, yeah. So that's 15 cubed root of 7x to the 5th. Now let me take care of the letter. Okay? How many x's are in there? 5 of them. How many do I need so in order to take them out? I need 3, right? I need 3 at a time. So if I take 3 away from the x to the 5th, how many are left? 2 of them, right? So this is the way they want you to write it, but you can do it in your head. But they say they should be able to split it up like this. Because 3 plus 2 is 5. So they're assuming you can do that. And now you have these matching index with that power right there. So you can take it out. So this will come out. So we get, so if we take out the x cubed, we get a 15x cubed root of 7x squared, and that's it for that. Right, we're going to do one more just to get you guys practice on it, because that's all your homework is, just doing stuff like this. Now, if you don't like the way this one looked, you can also do this, and it's up to you. From this step, you could have done 15 cubed root of 7x like this. Some people like to do that instead. And then they just say, well, cubed root means I got to have triples. So they'll circle this and say that comes out. And then what's left is x times x, which is x squared, right? So you still would get 15x cubed root of 7x squared. So it's the same thing, but some people like to write all the x's out and all the y's, but you don't have to. Are we okay with this one? So calculators are important. Let's do this last one. And I know I had one more, but we'll just go with this one, and then we're done. Now, if you happen to have two variables, by the way, just look at this last one we're not going to do. Don't freak out. It's just x cubed, y squared. Treat them individually, like x to the third, y to the second, it's a square root. So just take them out however many you need to. Don't let two variables scare you. Okay? So, not a big deal. So here we go. 7 cubed root of negative 625, 8a to the 8th. Now, is there a cubed root to negative 625? No? All right. So, can I divide 625? Let's see it by 125. Does that work? Yeah, it does. It does. So, 625 is 125 times 5. Okay? I use 125 because the number ended in 5, so I figured let's try doing something that has a 5 in it. But notice one of them is going to have to be negative, right? So let's just do this one. Negative 125. The one with the cube root. So here we go. And then right now you can use your calculator to figure out what happens. So negative 125 times 5, a to the 8th. What's the cubed root of negative 125? Negative 5, right? It's going to come out. And you're going to get a negative 5. Cubed root of 5a to the 8th. And that's negative 35. Cubed root of 5a to the 8th. All right. So, now let's deal with the variable. How many triples does a to the 8th have? Has 2, right? It's a cubed, a squared, right? If you want to break it down, a to the 8th is a cubed, a squared. Okay, because 3 plus 3 plus 2, that's 8. So I can take out 2 sets, right? I can take out this one and this one. And they're going to come out. And they come out as single A, so it's A and an A. What is that? When I take out 2 A's, it becomes a squared. So this will be negative 35, a squared, cubed root of 5a squared. And this is going to be your answer for that one. All right, so I'm going to go ahead. I'm going to stop there and then give you guys your homework.